Hi everyone, it's 4 o'clock here now in Dublin, so I will kick off this webinar, and I'd like to start by welcoming you all to our next episode in the Open Networking webinar series. Today we're looking at data center and service provider solutions with IP Infusion. My name is Ciara McCarthy. I'm the Global Marketing Director for EPS Global. Just to give you a bit of background on EPS, we're the open networking distributor of choice globally for a whole host of industries. So we sit at the center of the open networking ecosystem. So we bring together the hardware and the open network operating software, it's a bit of a tongue twister, together to create turnkey solutions for our customers. So we offer technical advice, configuration of software, and hardware bundles. That's your switches, optics, your cables, and more. We've been around for 20 years and we've 28 locations around the world, so we're never far away. So if I can introduce you to our speakers today, we have Barry McGinley firstly. Barry is our systems engineer for EMEA. He's our resident techie with a deep knowledge of open networking. Barry enjoys, so we're slightly behind here on the screen sharing, so I'll just give it a moment. Right, we're on the speaker slide now. Okay, so Barry, he is our resident techie and he has a very deep knowledge of open networking. So Barry enjoys a pint of Guinness and he's an avid Celtic supporter. I'll let him speak for himself later, but he writes an excellent monthly blog that is worth checking out on our website at epsglobal.com. So moving on to our first speaker from IP Infusion, that's Craig Schaefer, and we're delighted to welcome Craig to our webinar today. Craig is a Senior Director for the Global Channels and Alliances with IP Infusion. He leads IP Infusion's partnership sales globally and has recently launched the company's new Partner Infusion program. Having been in technology sales for more than 20 years, Craig has previously held leadership positions at WeWork, Voyager Search, HPE, Schneider Electric, Nortel, and AT&T. Craig lives in LA in California, where I'm sure it's sunny there. It's not as sunny here today in Dublin. I'd also like to welcome William Graves, who is a Senior Solutions Engineer for Global Channels and Alliances for IP Infusion. William, you're very welcome today. William provides technical leadership and support for IP Infusion's ecosystem of partners. He spent 18 years at Cisco as a consulting systems engineer for software management and orchestration solutions. Most recently, William was at Telco Systems, where he was the lead technical resource for uCPE sales into service providers. He lives in the Dallas, Texas area. So I'll just a bit of housekeeping before I hand over to Barry there. So if you have any questions, just type them into the Q&A window of Zoom and we'll get to the questions at the end. And if there's anything that we don't cover today, we'll respond to you personally after the webinar. So I'll hand over to you, Barry.
Ciara, can you hear me? Can you actually hear me there, Ciara? I think I have an issue with my audio.
I can hear you, Barry, yeah.
Okay, perfect. Okay, we'll go ahead then. That's
perfect.
Fine.
Great. Thanks, Barry.
Okay, thanks, Ciara, for the lovely introduction. And thanks everybody for joining us this morning or this afternoon or this evening. Because I did notice on the sign-ups, we actually had sign-ups from Australia, Asia, India, Africa, Europe, North America, and South America. So it's great to see open networking in all these kind of areas. So if it's morning, afternoon, or evening, thanks for joining us anyway. So I'm going to cover today, if I can get this to work. So the agenda, I'm going to have a look at the open networking ecosystem, and by that I mean where does the hardware actually come from and the end-to-end solutions. Craig is going to have a look at the corporate overview of IPI. We're going to have a look at trends in disaggregation and migration, and Craig is also going to look at IPI's relationship with AT&T and DANOS Vyatta. And William's going to take us through the use cases. So we have the cell site gateway or cell site router, as it can be called, the virtual OLT, software-defined edge, carrier Ethernet, optical transport with Cassini from Edge Core, and data center networking. We'll summarize and we'll take a few questions at the end as well. So, EPS Global, and Kira touched on it there. We're 21 years old, and we've been involved in open networking now since 2016. We got involved in this through being distributors for Edge Core networks. So for anyone who doesn't know Edge Core, they're an OEM, ODM out of Taiwan. They're owned by the Acton Group. And if you've used a switch that's not Cisco, you've probably used an Acton Group switch. So I think very early in our relationship with Edge Core, we realized that the normal rules of distribution weren't going to apply to open networking. So we had to go out there and evangelize about open networking. And we also had to talk to all the software vendors, not just some of the software vendors, all the vendors, because they all have their own little niche area. And this is how we have a relationship with IP Infusion. Some of the other solutions we provide for our customers. So we have the hardware, we have the software, but like when customers come to us, they love the idea of disaggregation, no vendor lock-in, obviously CapEx savings. But how do you put all that together? So we do that for our customers. So we'll put the software licensing onto boxes. We can brand boxes for our vendors as well. We can bundle in transceivers, stacks, all sorts of stuff. So basically, the switches are ready to slide into a rack when they arrive at the customer data center. So that's what we do globally. So on the hardware side, I'm going to talk about the Open Compute project. So the uCPE were founded in 2011, founded by Facebook. I'm not going to go into all the reasons why, but basically the way it works is anybody who's a member can give in a hardware specification. So we'll say EPS are members. We say we're looking for a 25 gig switch with 400 gig uplinks. So that's our, obviously a little more complicated than that, but that's our basic design our hardware specification. Then companies like Edge Core will go off and they'll give in design files. So design files based on the specification. If they're accepted by the OCP, Edge Core will then go off and build the product. And then the product gets accepted by the OCP. It's now an OCP accepted product. It will move to the OCP marketplace. And it's actually interesting to look at if you were interested, we'll look at all the products that are OCP accepted. And they also have a close relationship with the ONF and TIP. And this is where we get our end-to-end solutions. We'll have a look at that now. So the ONF started a couple of months before the OCP in 2011. I suppose they started originally to kind of, they're saying evangelize software-defined networking, open networking in general. They looked after the open flow protocol, which was the first protocol to separate the control and data planes. Then in 2014, they released OcNOS, which is their open network operating system. That's actually more of a controller now than an operating system. But the important part for service providers is in 2016. So in 2016, they began work on a platform called CORD. So CORD is central office re-architected as a data center. I suppose if anyone doesn't know what the central office is, they're usually kind of grim-looking grey buildings. You'd walk past them and wouldn't even know. And they kind of house OLTs, switches, routers, some backhaul stuff, transponders, broadband network gateways, things like that. So it's the last part of the service provider network before you hit the residential and enterprise. So within CORD, we have a whole heap of projects that run. In 2019, the first reference designs were released. So SIBA, software-enabled broadband access. So that's our OLTs. Trellis is spine and leaf architecture within the central office. And ODTN is their open disaggregated transport network. Like that's optical transport, and we're actually going to cover that when we look at the telecom infra project. So 2020, they actually started rolling out some of these. So OMAC was rolled out by T-Mobile. Trellis is working in Comcast's production network for telecom. I've rolled out SIBA. And I suppose only for what's happened over the last 3 or 4 months, AT&T and Deutsche Telekom probably would have SIBA working in their production network as well. There's also an awful lot more of their projects in field trials at the minute. So within those 4 years, they've got a lot of work done, and it's fair to say. So just to look at some facts and figures on it. 650 Dynamics, the report recently, when they surveyed a heap of the top service providers. And between 2020 and 2025, the spend in this area is going to be 490 billion. So that's RAN, broadband access, service provider router, optical transport, and evolved packet core. And just on the ONF projects that have been released so far, 73 billion of that 490 billion is the market opportunity, which is huge. And when we look at telecom infra project now, it's going to take another huge chunk of that. So the telecom infra project. So again, they started work similar time to when the ONF started their core project in 2016, and they work very closely with the ONF. So an awful lot of the membership would be part of the ONF and part of the telecom infra project. So there's no point in Telefonica or Deutsche Telekom working in projects that are the exact same. And there is slight overlap, but not too much. And they also work closely with the OcCPE. So all the hardware, the majority of the hardware actually, because I think the Cassini was the telecom infra project, comes from the OcCPE. And the 500 member organizations involved now. And when you look at the caliber of those 500, it's quite impressive, to be honest. In 4 years, they have a marketplace called the Tip Exchange, which is similar to the OcCPE's marketplace, where you'll find the products that are involved in these end-to-end solutions. And project-wise, they have 3 distinct areas. So the first one is access, and that's all their RAN initiatives. So we have Open RAN, I'm sure the majority of people know about, Open Cellular. The second part is backhaul, so from the mast back to the core. They call the transport. We have multiple projects here again. I'm going to look at one of them in a second, just to give you a snapshot of how it is an end-to-end solution. And the third area is core services. So there's some end-to-end slicing projects. There's some orchestration projects, I think, as well. So briefly, before I hand over to the last one, I'll look at one of the projects in the transport section, and that's the Open Packet Transport. So the whole OPT. So we look from the left, we have a user on his mobile. The mast picks up the signal down to the baseband unit and into the cell site gateway. So cell site gateway was born in the OcCPE, UFI space, edge core networks with OcNOS sitting on top of it, or DANOS Vyatta. Then we're into an aggregation router, again, born in the OcCPE. It sounds like a song. An edge core box with OcNOS sitting on top of it. And then depending on distance to get back to your core, you have an optical transponder, which William is going to cover in a little while. The optical signals muxed, amplified depending on distance, and back to our core. So that shows you a proper end-to-end solution in a very, very short amount of time. So I said, that's a snapshot of open networking for service providers and where the hardware is actually coming from. I'm going to let Craig now tell us about where IPI sit in all of this.
All right, Barry, thank you.
No problem, Craig.
Yeah, it sounds like the audio was clipping a little bit there, so hopefully my audio is a little bit better. So let me know if we're still clipping, and we'll figure something out. So yeah, great. So thanks, Kira and EPS Global for just the opportunity to spend some time with you guys here today. So really appreciate you being here. And we're going to take you through kind of an update on IP Infusion and an update on what service providers are doing in the open networking space. It's been, just in the last 12 months, there's been a ton of changes relative to what's happening in the industry. And so we just wanted to kind of bring everybody up to speed and bring you up to speed with regard to what's happening at IP Infusion. So I am based here in Southern California, although Kira likes to dream about the fact that it might be warm and sunny here. It's not. It's what, a little after 8 a.m. in the morning, and it's gray outside, but it will be sunny in the afternoon. So that's good. We have that going for us. So a little bit about IPI. We've been in business 20 years, and a lot of people don't realize that. So many other open networking vendors have come about in, let's say, the last 5 years or so, but IPI has been around for 2 decades. And our founders were at the very forefront of everything that's been happening in open networking over the years. And our founders wrote the original Zebra OS code. And interesting fun fact that that forked off into Quagga. And if you didn't know, Quagga is an extinct form of Zebra. So there you go. That's where Quagga come from, and that goes into free range routing, and then ultimately to where we're at today with our flagship product as a company, OcNOS, Open Compute Network Operating System, but also DANOS, and we'll talk a little about DANOS Vyatta Edition and what that means for everybody on the call today. So Barry, why don't we just move on and ecosystem wise, open networking is all about ecosystems, and we are engaged with a ton of players throughout the industry. So we'll start off in the bottom left with regard to all of the optics providers that we deal with on a regular basis. We deal with silicon merchant providers, or merchant silicon providers rather, on a regular basis to make sure that we've got the most open ecosystem and the most open hardware environments for our software to land on. And from a hardware provider perspective, that rings true. So Barry mentioned EdgeCore, one of several platforms on which we reside, but certainly one of the most strategic that we have in our portfolio. And we're clearly involved in all of the industry foundations that Barry was talking about, from OCPE to TIP, et cetera. And we'll talk a little bit again about DANOS. So just moving on. So, I don't really want to get into the background of open networking. I think most people, if you're joining this call, you're familiar with what's happening in the industry, and it really kind of all started back when telecommunications has really evolved from mainframe type of environments to the server environment, and x86. If you've got a box, the ability to load a Windows operating system or a Linux operating system on that box. I mean, disaggregation has happened in the x86 architecture for a long time, and move that into the data center where we really got away from having to have a proprietary solution in the data center, and white box has been prevalent in the data center for quite some time. But now we're really moving towards the service provider part of the network, and it's really creating quite a bit of opportunity and quite a bit of innovation on the service provider side, from software-defined networking to network function virtualization, NFV. All of these things are playing strongly into our hand as we focus on the service provider solutions going forward. So Barry, if you could. So just some additional market trends. 5G obviously is creating a bunch of new opportunity for MNOs and for consumers alike. And as demand for 5G takes off, that creates a tremendous amount of pressure on the network. Public cloud adoption, I think that goes for itself. I mean, enterprises have been really looking to, how do I get to the cloud as quickly as possible? How do I analyze the workloads that I'm taking for both my in-house network, my on-prem network, as well as my cloud network, and what I'm putting off into the cloud? And I have to make sure that I'm making the right decisions there. And then again, from an SDN perspective, really what people are landing on is the fact that hybrid networking is really where the sweet spot for our industry is going to lie. And how do you manage that? How do you create the right network environment to take advantage of all of the options that you have there? And I'm just kind of looking through the comments as we go here. So is just a little check here. If the audio is okay, just let me know in the comments, and we'll keep going forward. So Barry, if you could,
perfect now, Craig. Yeah, it's great.
Okay. Excellent. So, excellent. So, disaggregation being the key to open networking, I think that speaks for itself. I mean, open networking is all about how do you manage the best of breed, the best options available to you. So you can take advantage of advances in media and other parts of the network and really optimize your hardware and your management and control plane to make sure that you've got all the facets of your network operating optimally to achieve the solutions that you're trying to achieve. And that's what open networking does. And IPI, because we've been in the business for 20 years, we've been creating feature sets for networking longer than anybody else, quite frankly, in the open networking space. So we came to, our core business for the last, I'd say from the first decade of our existence was all about how do we provide protocol stacks. So if you're a network equipment manufacturer and you wanted to add MPLS as a feature to your product, you could go hire people, code that in-house, or you could come to a vendor like IPI and you could buy that protocol stack and incorporate it into your product. So we've been doing this for 20 years. As a result of all of that development over time, our Open Compute Network Operating System, or OcNOS, has come to be the most fully featured open networking NOS in the industry. So Barry, if we can move on. So why do you do this? I mean, you know, if you're on the call, you're considering open networking, you're considering IP Infusion perhaps in partnership with EPS Global, and you do it because, number one, open networking has this promise of CapEx savings. You can buy your optimized hardware from vendor A, you can buy your optimized software, your network operating system from vendor B, and you know, any other components, be it optics, et cetera, from other vendors, and you can really put this best of breed solution, and you can buy it at price points that are different than what you could buy from a proprietary vendor, a legacy vendor, if you will. And so that CapEx savings is obvious. But the OpEx saving is oftentimes overlooked. And I think it's one of the strengths of IP Infusion in that, because we're not just selling point solutions in the network, we're really providing what I would call architectures. We're selling architectures because we've got so many diverse use cases that William will talk to in just a moment. But because of that diverse set of use cases, that provides the opportunity to deploy a common NOS across your infrastructure and really gain those efficiencies of both, you know, let's say training and sparing and things like that. All of those things come to the fore. And now we're talking about an equation in terms of economics that results in both CapEx and OpEx savings, which is really kind of, you know, a different perspective for open networking, I think. So next slide. So as I said, we're really talking about selling solutions and not just point products. So as a team of IP Infusion and EPS Global, we really consult with our clients and really understand what's the use case, what's the solution we're trying to tackle. And from there, we select the hardware, the best of breed hardware, be it optics and or, you know, white box. And then we really talk about the features and the software that we need to deploy. And we've got some different options in terms of open networking NOSes that we can deploy. And then together with EPS, you know, one of the things about open networking has been that, you know, if I'm a consumer of this technology and I have to go out and procure hardware over here, and I have to go procure software over here, and then I have to support it somehow without having to do this and point the finger at each other, I really want that one person that I can go to and get support from. That's where the value of a partner like EPS Global comes in with IP Infusion, that we can procure all of the facets of your solution from a single vendor, and then make it happen for you from a support perspective, so that you've got that trust, security, that risk aversion that people are sometimes looking at when it comes to open networking, and we've got you covered on that front. So very final slide here, I believe. Last thing about IP Infusion, this is an update. This happened in the fall of last year, so I wanted to make sure that everyone is clear on what's going on. I said that IP Infusion's flagship product was Open Compute Network Operating System, or OcNOS. AT&T and IPI partnered in the fall of last year, whereby IPI would be the exclusive worldwide distributor of the DANOS Vyatta Edition software. So DANOS stands for Disaggregated Network Operating System from AT&T. This is a product that came from originally out of Vyatta, which was Vyatta was purchased by Brocade, and when those Brocade assets were being looked at by Broadcom, it was spun off, and AT&T wound up with those assets, and they created the DANOS software. So DANOS is open networking in that it is hosted by the Linux Foundation. You can go out there today and download DANOS software. And then IPI, we offer the DANOS Vyatta edition of that. So if you're familiar with you know, this type of solution, it's one where the DANOS available to download for free, you've got that. You can absolutely do that today. But if you want the hardened, curated, supported version of that software, you would get it from IPI and our partners. And that's what we do with DANOS Vyatta Edition software. and a DANOS Vyatta Edition, or DVE as it will be referred to throughout the remainder of the presentation, is something that AT&T is consuming in their own network, deploying more than 60,000 cell site routers in their own network, and it's got other use cases as well that we'll talk about. So Barry, one more. All right, so that's in conclusion, that really leaves us with the two operating systems that IPI goes to market with today, which is number one, the DANOS Vyatta Edition from AT&T, and there's a number of use cases involved there, but the two primary ones that we're focused on are cell site router, or DCSG, Disaggregated Cell Site Gateway, and the uCPE, what we call here at IPI, Open SD Edge, and William's going to talk to those things in particular, and then OcNOS as well, where we cross a number of use cases with OcNOS. Again, with that 20-year heritage of IPI, it really comes to bear with regard to OcNOS being what we believe is the most fully featured open network operating system in the industry. And so you can kind of see the use cases there. So the next slide is a transition slide as I pass it off to William to take you through the various use cases. This is a helpful slide, and I look forward to everybody getting these slides after the call today. But this kind of breaks down the use cases where IP Infusion plays, but also the network operating system that we would recommend when it comes to those various use cases, be it universal CPE or VoLT, which we'll talk about in a little bit. But that's really where we're going here. And so as I toss it off to William, and we'll come back and summarize things, that's a little bit of an update as to where IPI is going. Barry's done a great job of outlining where open networking is today and where EPS is playing. And really, now let's talk about how we dig in with some of these network operating systems and solve some of the solutions that service providers and data center people are looking for. And with that, I'll toss it over to William. William, over to you, sir. I think you're muted, William. No, still muted.
That better?
There you go.
All right, so yeah, once again, we get bitten by the headset manufacturers. Kiara, I hate to tell you, it's not sunny in Dallas. We're taking a break from the heat engine that usually kicks in this time of year. So we have showers today. So actually it's a little humid, but quite pleasant compared to what it normally is.
Makes us feel better here.
I'm extremely excited to talk to the EPS and the folks here joining the webinar. I've been at IP Infusion only a couple of months, and it seems like a couple of years already with all the different things that we have going on from a use case perspective. And I guess kind of want to take a segue on this and kind of talk about our capabilities. And we're going to go from the access to the core. We have a lot of things going on in the access, and I think the addition of the DANOS the DANOS software has brought us some unique capabilities that bring us into the realm of CPE, which is not an area that IP Infusion has typically been in. And what's unique about that particular piece of software, the Open SD Edge, is that it's sort of this really Swiss Army knife type deployment, in the sense that it can be a V router on one day, a bare metal white box router on another day, and with an upgrade, a universal CPE on the day after that, which makes it a very interesting product. What's unique about that is that from both the data center as well as the access, I have the same operational experience in terms of bringing things together from an end user perspective. And the universal CPE access just allows me to extend that with whatever third-party DNF that customers want to run today. A lot of those being things like SD-WAN and next generation firewall, where people are starting to consolidate their appliances into one single hardware platform and running those applications as NFV-based applications in the network, offering them a considerable amount of flexibility they didn't have before. So we're really excited about the Open SD Edge and where we're going to go with that with the DANOS Vyatta software. And then later this year, we're going to be bringing a PON solution to the market. It's also virtualized, and it's virtualized in two ways. One, sort of a chassis-based solution and a pluggable solution. So we'll get into that. And then our overlap at the CSR level with both DBE and OcNOS gives us a plethora of options to go into the cell site market with. And we'll talk about some of those requirements as we move forward. And IPI's disaggregated tradition primarily starts from the data center on out. So, we still have our CLOS technology that we can bring forth in the data center, and IXP peering technology that we've been focused on as well. So as Craig says, is that, in a fairly short period of time, we've gone offering point solutions to architectures, particularly when we start to add in some of the disaggregated optical functionality that we want to bring to the table or are bringing to the table at current. So Barry, you can move to the next slide. We'll get into that. I thought I'd start off with the cell site router use case, since it seems to be pretty top of mind of most people. And sort of the way to look at this is as follows. You see changes happening in a lot of the radio architectures, the RAN architectures that are happening in the network based on 5G. And, you start off with your typical classical architecture, which is sort of everything in, sort of one integrated BBU unit. And you just simply have backhaul of the protocols back to the mobile core. And there, that's a pretty known architecture. It started off as 1 gig, then it went to 10 gig. And if you're talking rings now, it's probably moved up to 100 gig because the bandwidths are for LTE and the amount of data people are using has been steadily increasing. But with 5G, what you see is a lot more disaggregation, if you will, of the RAN itself. And this kind of starts off into where we have an integrated, we have disconnected unit for the radio, a distributed unit, and a central unit. And those are disaggregated from one another, meaning they're distributed. Now, with the proprietary vendors, a lot of those things are set up to where all those pieces belong to those vendors. Most of the folks who are deploying these things are kind of in that distributed cloud RAN area where the RU and the DU are this sort of proprietary pair, if you will. And then you have a mid-band type of architecture and a backhaul architecture that sort of kind of comes out of that. And from that, what you see is the need to put a CSR in to address the bit haul and the backhaul based architectures. And if you continue to extend that where the radio units become disaggregated, you now start to add these front haul architectures as well. Each one of these brings a different set of requirements. While the interface requirements are fairly similar in terms of being 10, 25, 50, and 100 gig, the latency requirements and the timing requirements really get pretty tight. And if you bring in the radio piece, you get into this whole issue of needing to deal with CPRI, eCPRI, and radio over Ethernet. So our current solution is focused on primarily on the mid-haul and the backhaul areas. In the mid-haul areas, we can address the latencies that are down between 1 and 5 milliseconds, and the backhaul, those are typically less than 20 milliseconds. But more importantly, we can handle the timing requirements, which used to be around 15 to 20 nanoseconds. Now those have moved down to 1 to 5 nanoseconds. And that means that, these deployments really haven't changed in terms of their topologies. What has changed is the fact that you're now pushing these things closer and closer to the radios. So we support the traditional topologies. We're using the TIP vernacular. So, we have our base topology, which is basically operating the CSR as a router, sort of a customer edge, if you will, in a dual home, IP MPLS network or any other network. We can just simply dual home the routing piece, because the focus here is primarily on the routing protocols needed to interconnect back to the PE. But we've also focused a set of requirements to where we can handle the additional service and transport requirements needed to deploy this thing as a provider edge router, so we can actually cover the PESW or MPLS profile from the tip. So we can move on to the next slide, please. So I talked about earlier, we have our virtual OLT, and what's unique about this particular setup is that if you look at what's happening in the industry, we're migrating from these sort of chassis-based legacy solutions to more of a distributed solution. And distributed is not only in terms of where the particular hardware can sit, but it's also distributed in terms of the software. So basically you can have an OLT offering either from a chassis or from a pluggable all managed by the same OLT control plane, which is virtually deployed either perhaps in an aggregation switch or maybe even in a data center. And then that kind of flows into the other disaggregation that's happening here with the BNG and the virtual router as well. So you see a complete disaggregation, if you will, upon architecture. So you no longer are geographically bound to the big chassis, that you basically can distribute the PON across a number of geographies that make the most sense for you, but also operate this thing sort of as a central kind of distributed mechanism, but operated as a centralized node, if you will. Next slide. Our OpenSD Edge, as I talked about before, we sort of have 3 use cases if we look at it specifically from the branch office perspective. One of those is just a standard white box branch office type of mechanism, and I don't want to call it an integrated access router, but that's sort of what it is. But this is white box based, so now you buy yourself an x86 uCPE, or if you want to host it on one of your internal servers in the branch, you could do that as well. And now you have your access routing. You have the option of pushing that out into a data center and maybe positioning a very simple NID, if you will, on the customer prem, and running that particular virtual function in the data center itself. And then last but not least, where you see a lot of folks moving to is this the idea of a universal platform to host all of my branch applications. And that's the uCPE. Next slide, please. I would be remiss if I didn't bring up good old-fashioned carrier Ethernet. I hate to call it old-fashioned, but I guess at this day and age, it is sort of old-fashioned in the sense that it's tried and true. This is the bread and butter of the service provider networks in terms of a lot of their deployments and a lot of their transport. And we have a full offering both from the access, the aggregation, and all the way to the core, if you will, where we're not really playing in the core, but we're playing from the edge all the way out to the access for a VPLS-based layer 2 VPN transport. Also, we support things like 8032 rings as well with the full OAM suites that are typically required for these types of deployments. Next slide, please. I think, the use case, one of the use cases that Barry outlined was the Cassini. And what we try to do is take one slide and show you all these use cases, because it's kind of really a unique technology, given that we can kind of break things up. And that is, we can kind of match the optics in this type of technology for the required transport distance. So let's say we only want to go somewhere in a metro that's very short. We can use maybe a PAM4 QFP28, which will get us up to about 80 clicks. Or, we can start to move into more of a digital architecture like a DCO, which will give us a little bit more flexibility in terms of distance. Or we can start to look at going long haul, which is more of a ACO type architecture from the optics. And those distances can be in the thousands of miles with amplification, et cetera. And what you see here is a very flexible, very interesting architecture that I can basically match my optics to my application. And that has a lot of power in terms of simplifying the cost per bit and lowering the cost per bit. And this kind of tied into the rest of our architectures when we started looking at it from a data center perspective or a service provider backhaul perspective, because from a data center perspective, we do have a data center offering. So, you could use one of our offerings to build a data center and then use another offering to interconnect those data centers. And in the backhaul, we could actually move into the same type of setup for the cell site router, et cetera, so forth and so on. And I see some of the questions you guys are asking. I think we can meet those at the end. I think they're very interesting questions as we move forward. I'll move on to the next slide. And I want to move into the data center here. We talked about our traditional spine and leaf architecture, which is the typical 3-tier type architecture, and how we can interact that architecture with our DCI architecture. One of the things that closes into this with our work with DVE is that as a virtual router, we can deploy that router into the data center. So now it also gives us a multi-cloud interworking technology. So I can have the interworking between different virtual private clouds, between a virtual private cloud and a public cloud, and then between the public cloud and maybe even a customer prem type device, whether that device is in the data center or on premise. So you have the same operational experience across interworking these different clouds. So if you want to run a VPN between these various different locations, you'd have the same experience in deploying that particular VPN. Next slide, please. So I'm going to turn it back over to Craig, and that way we'll have a little more extra time to answer the questions that I see on here, and we'll let Craig summarize everything up.
Yeah, well, gotta love the marketing slide to conclude things. But yeah, I mean, look, this is William's done a great job of kind of outlining the various use cases that that IPI is involved in, and that we would love to have conversations around in conjunction with EPS. But at the end of the day, this is all about deploying best of breed solutions and cost savings. And really, when I say cost savings, I mean total cost of ownership savings. And I think we've kind of hammered that point home a little bit here today. I think when you look at IP Infusion, it's really about the history that this company brings, the 2 decades of leadership in open networking. And what that 2 decades worth of development brings is the most fully featured network operating system, open networking operating system to the market. And when you have the most fully featured network operating system, that allows you to get deployed in a diverse set of use cases that William just ran through. And when you're deployed in a diverse set of use cases, now you're starting to talk about the same technology being deployed across the network, which now results in OpEx savings. And that's a tremendous value that I think IPI brings to the table. So with that, Kira, I don't know how you want to do this. Do you want me to facilitate the Q&A, or would you like to do that, or would Barry like to do it? I'm not sure.
You can go ahead. I think Barry just had 1 or 2 more slides quickly to run through, and then we were going to jump on to the questions.
Perfect.
Because I think we have 2 really interesting questions there. So Barry, I'll leave it to you.
Grant, well, just to finish up, we've upcoming webinars, data center automation with Apstra, Pluribus Networks on their Fabric and their new monitoring solution, Pika 8 on campus, and then we're going to have a live Q&A in October. We also have some good information on our website. So blogs I've written, white box products for the carrier networks, stuff on tips, stuff on OCPE, fabrics, so on and so forth. You can have a look there. But I think, yeah, we can go on and we can take the questions now. I can't see them here. So if you want to call them out, Kira, or...
Yeah, no problem. So the first one was from Dan Pitt, and it was, could you build the PON bridge with an all optical switch or interconnect?
Do you want to take that one, William?
That's an interesting question. So I think the way I'd like to describe it is that when we look at these distributed PON architectures, we can kind of mix and match a few different things. So traditionally, if you had a PON cabinet, et cetera, so forth, you're kind of stuck in the chassis. Here you have the option to use things like DWDM transport to extend out to your virtualized PON. Because remember, you're running your controller separate from where those chassis are. So you can actually distribute the PON in sort of very interesting ways. And if I understand your question correctly, there are ways that you could backhaul, let's say a wavelength, for example, for let's say a PON location that may be in some remote area that could be mixed and matched with things that are coming in on traditional fiber into your overall PON deployment. Does that make sense? And hopefully I got that right.
Yeah. Kira, is there any more? I can't see them.
Yeah, there was another one. Yeah. So Dan, we can also follow up after if there's any other questions you have related to that. So Matthias asked, do you know some case that uses uCPE or vCPE with XPON network, GPON, XGS-PON, or TWDM-PON?
I am dying to go find an XGS-PON use case, because one of the exciting things about the pluggables that we have is there's also an ONU that's a pluggable from the same company, which is called Tibit. So as we are in the uCPE business here, we would love to work with you to identify such use cases. I do believe they will happen. I think it's just going to depend upon the deployment topology in the metro as to whether or not, the particular provider wants to connect via PON or use a traditional fiber Ethernet type technology. But if you think you have a use case, please shoot me an email. I'd love to work with you on it.
Great. Were there any other questions there from anybody? I think that is it. We've just got thank yous coming in there. So yeah, I mean, thank you everybody for joining us today. I think our speakers were excellent, even if I just do say so myself. What we're going to do is we're going to send out the slides after this and also the recording. But what we're going to do is try and fix up some of the audio issues that Barry was having there at the start before we send it out to you. So it'll just be a few days before we get that to you. So and any other questions that, after you digest this, if you have any other questions, just shoot them over to Barry there. He can share them with Craig and William. His details are on screen there. And thank you very much, everybody, for joining. Have a nice day.
Thank you all very much.
Cheers,
Thank
guys.
you.
Cheers, guys. All the best.
Bye.